Hi, my name is Frieden, and this summer I worked on a project dealing with the accelerometry and local field potential modeling for closed-loop deep brain stimulation of essential tremor. Really quickly, a little bit about me. I'm originally from Iowa. I attend Iowa State University, and I expect to graduate in May of 2023 with a Bachelor's of Science and Engineering in Software Engineering. This summer, I worked in the SURF program in the Herbert Wertheim College of Engineering, Electrical and Computer Engineering Department at the University of Florida, as a member of the OWISE lab under the direction of Kareem OWISE and my mentor, Dr. He Zhang. OWISE lab is a multidisciplinary space with multiple areas of focus in the domain of neuroscience. My project primarily dealt with the brain-machine interface for treatment of damaged neurological function. One of the main projects in OWISE lab right now focuses on treating essential tremor. Essential tremor is a progressive neurological disease with a strong genetic component that is characterized by high-frequency tremor, especially in the upper limbs, while performing goal-oriented movement, such as eating or writing. DBS is an effective treatment for various neurological diseases and disorders achieved by electrically stimulating regions located deep in the brain using surgically embedded leads, such as the ones pictured here. OWISE lab is currently engaged in a clinical trial using dual-lead DBS system developed by Medtronics called the Summit RC plus S system, which have been implanted in two regions of the thalamus called the VIM and the VO that are located in high proximity to one another. The core hypothesis of our work is that these high proximity leads can provide improved electrical stimulation and sensing by enabling a high-quality closed-loop operation. Closed-loop operation means that the system is able to internally and computationally determine and vary the stimulation parameters and delivery of DBS therapy. Currently, most DBS relies on an open-loop system that provides a steady and constant electrical stimulation to the brain. However, this has many negative side effects, such as impacts on ability to speak and a process known as refractoriness, by which the brain can become resistant to electric therapy. Additionally, open loop systems also have significantly shorter battery life and require significantly more frequent surgeries to replace the batteries, which are often located subdermally in the chest of our patients. Getting into the weeds a bit on my project, my goal is to use local field potential data to create a model of the expected 3D acceleration data from our patients as they perform simple day-to-day tasks such as writing and drawing. Currently, we have a motor intent prediction system using something called a linear discriminant analysis that is able to predict motor action roughly a second before it occurs. My job was to create a full accelerometry profile using local field potential data so that we could compare it to the accelerometry produced when a patient is being treated by our best open loop DBS in order to more accurately inform our choices about our closed loop DBS parameters. Parameters of closed loop DBS include things such as the frequency and current of the electric stimulation provided, as well as when it is provided. That said, the results of my project, after about 5 weeks of literature review, lab exposure, and clinical trial observation, were that I was able to produce a convolutional, long short-term memory model. However, it is in need of some refinement and tuning. As the graph on the right shows, the model was able to converge to a lower error value. However, we believe that we can further improve its accuracy and lower the overall range by working on our data processing pipeline, performing a network redesign, and a network parameter sweep. The goals of these are to provide higher quality data to a more appropriately designed network with highly tuned parameters that control the final output of our network. With that said, at this time, I'd like to offer a quick couple of thank yous and acknowledgements to Dr. OWISE and Dr. Zhang for being great mentors and for giving me the opportunity to work with them in OWISE lab, and to the SURF program coordinator, Dr. Mike Nazareth, for putting this research experience together and for providing a bunch of excellent professional development and social activities over the summer. It's been a great experience, and go Gators.